revenge. Nah, just kidding. Welcome to Friday Night Live. If you guys don't know me, my name is Miss D. I'm a certified welding educator. I'm a certified welding inspector and a certified radiography interpreter. I'm here to teach you guys the science of welding. Okay? Yay! So, today we will be working on blueprint tools. There was some questions that was asked this week in our daily assignments, and everybody had no idea. Okay, so I want you guys to have a better idea because these tools are used in layout, they're used in fit up, they're used all in industry, and you guys need to be familiar. Okay? All right. So we're gonna talk about this. If I have to, I'm gonna be drawing lots and lots of pictures. Okay, so the first thing we're going to talk about is a face plate. Really what a face plate is a piece of material that we know is true and square. Okay? In some places it will be machined down so it is flat. Why is this important? Why do we need something that's flat to work on?
Because it's level.
Right, so what happens if our stuff is off level? Right? The leg's gonna be crooked or whatever it is, it's not gonna be true. Okay? So that's what a faceplate's there for. It's true. Now what's really cool about actual faceplates that you use, there's actually lines that are scribed into it. Okay? Which allows you to build a weldment and know that you're square and true. Okay? That's what's really nice about it. And if you notice, they down here on this, okay, it shows that there's lines on it. Hey, how does this reference this? Now we start to understand how they reference each other. Okay, so that's very important. So when we reference things, we might like to use right angle, parallel, or perpendicular. Okay? That makes it easier for us to understand just a little bit better. Okay? So we're not going to go through entirely everything, but I want to make sure that we at least go through all the tools, okay? The next one. This is an angle plate. I learned it as an angle block. What this is, it's this one right here. Okay? And what this is an actual, it's like two plates, and you're able to change the angle to it. So usually they'll have some that are fixed and fixed at a 90-degree angle, which means that you can build on the other side or clamp to it to make sure you are exactly straight up and down, right? Okay, so it makes it a lot easier to use. And then we can also adjust it to whatever angle or degree that we may need it at. Okay, so this is a very helpful tool, especially when we need to be very precise with a specific angle. Okay?
Oh, it's a tool that you put the other pieces.
Right. So if you notice on the other side, it shows right here that this is another piece that you can put up against it and make sure that it's going to be square and true, right? Remember, these tools are made to make your life easier. It also allows you to be more accurate when you make your weldment, if you're doing assemblies. Okay? Remember this. The other one, okay, this one was actually in the assignment. This is a V block. Okay? Now, what it does, it's actually kind of like a little notched block. Okay? And it allows you to stick it up against your weldment and tack it. So now if I have a pipe that's round and I'm supporting it, now one end's not going to go like this or like this when I'm trying to tack it up or stick something underneath it to make it stay.
You can tack the block to the
Well, not the block. So what you'll do is that you'll actually put the block itself underneath something if it needs to go higher or lower. But what the block does, it supports your pipe or the material that's round. Okay? And so it doesn't roll away on you and move on you. That's the hardest part about doing pipe. Or maybe I need to just tack two pieces together. Heck, you put two pieces in there, tack, roll, tack, roll. It's fast, it's easy, and you don't have to worry about misalignment. Okay? That's what that tool is for. Now, if we look at it, on this bottom part, they're actually using two little ones, two little V blocks here to support a longer weldment. Right here on the bottom one, okay? So notice that you can use it in different ways. All right, so, okay, here it is. Wait, while we're still looking at page 131, tell me, since we kind of went over some lines last week, what is the long, short, long that's in the middle of that pipe? What is that called? What type of line is it? I want you, well, look at it, and I want you guys to tell me, what do you think it is? Come on, guys, feedback.
It's not the
Pizza ain't free! Sorry, Jen.
It's not the continuous of it, is it?
No, it's not the continuance. Page 131, okay? I want you to look, that it's a long, short, long, right in the middle. If it shows the middle, what is it?
If it shows.
Yes! Thank you very much! It's the center line.
Oh, that makes sense.
It tells me it's the center. So that way I know I'm, dead center where it needs to be, right? Now, there's some dashes next to it. What are those dashes called?
The one above it?
There's some dashes above it and a dash is below it. What are those dashes called? Huh? Good, nice job, Sambino. They're hidden lines. So what do hidden lines do for us? Well, it shows me that there's actually an interior wall. When we see it like this shows me it's a pipe. Okay, so I'm seeing the interior wall of the pipe. Okay, so it's important to see some of these things, how they're laid out, so that you can better understand it when you actually see a blueprint and go, oh, okay, we're good. Instead of, oh my goodness, I don't know what I got myself into. Huh?
Why would you see the inner part of the wall? I'm confused.
Say that again?
I'm confused on the purpose of these lines.
Okay, so, well, the center line tells us the center. Okay, the other one is that we need to see the inside wall of the part. So if I have a pipe, right, how thick is the pipe? That's what we're showing.
Oh, how thick it is?
How thick it is, and it's called the wall to the pipe, the inside. How thick the inside is, okay?
All right.
That's what it is. All right, let's go a little bit further. All right, so the next one, let's see what the next one is. Parallel bars. These are my favorite. Parallel bars are used quite a bit when we do CNC machining, okay? I learned to be a machinist, and what these are, it's kind of hard to describe, but what they are these little tiny blocks. And each block is precision machined. And it can go from a 1/4 inch all the way to a few inches. Okay, so these blocks are precision made so that when you place them on your faceplate or you face them anywhere else and put something on it, we know it's going to be true. Okay, and it's usually meant to hold weldment up and arrange it, like if this needs to be 3 inches off the ground, then we can set it on there and know that we're going to be exact. Okay, so these are precision, and they're called parallel blocks or parallel bars. Okay, so as we can see in some of the pictures, it shows that the faceplate is right here, and it shows the little kind of slanty lines as the parallel bar to show you, oh, it's lifting it up. Okay, so understand how it works, and then we can also see that, oh, look, so now it shows from this distance to this distance, this is how tall the parallel bars are. Okay, so then it makes it a little bit easier. All right, next. Y'all know what a C-clamp is?
C-clamp?
Yeah.
Good. We're not going over that one because If we have to, I need to kick you in the pants now. All right. But there's a bunch of different ones. A steel bar clamp. These can be a bar or a pipe, and I have some at my shop that are about this tall, okay? And what they are is a little kind of gadget here that you can slide up and down the size of it as a clamp. So it'll hold your weldment if it needs to be held in a larger area, okay? So it's pretty much just a big giant clamp, and usually it's for extremely large weldments. I used one on my truck. I was making a frame and I needed to put something in there, so I got a really long one and squished it in there so it would stay. But it was probably one about that tall. Okay, that's only like 5 feet, so. Okay, so really that's what it's doing. Now, I want to show you guys this question it asks. This is really important to think about, okay? So the distance between two vertical members, what is vertical? Up and down, right? Okay. And it says it's required to be 34.5 plus or minus 1/8. What is that called, guys?
Tolerance.
Tolerance, good. What does it do? Help explain it.
It's me. Good. Good. I didn't want to go back to her, girl. How you doing?
Yeah.
Good.
All right, so what does it do? Tolerance does what for us?
Helps with accuracy, like knowing what difference in the amount of difference in measurement that you can have without going outside the accurate range, I guess.
Okay, good. So it helps with actually fit up. Okay? So when we say that, we're saying, when we see that plus or minus there, it says it can be over 34.5 by 1/8, or it can be less than by 1/8. Okay? So it's giving us a lot of information there right off the bat. And then it's asking what is the minimum and the maximum. So which would be my minimum? It would be the minus side, right? And my maximum? The plus side, right? Okay, good. So that's what I'm talking about, okay? But then they ask another question. They say, how many inches must these members be moved to be within this tolerance? Right? So it says that it's 36 inches, and I have a 34.5 plus or minus 1/8. So what does that do? Well, now I have to move this because right now they're sitting at 36. You see what I'm saying? So like we have to make sure we pay attention not only to our measurements, but to the tolerance and what they're actually asking. All right, straight edge. Tell me guys, what is a straight edge?
A straight edge blade.
Because I know you guys know what a level is, because we're not going to level. What's a straight edge?
It's to make sure the edges are straight.
That's a good point. Yes, it is. Actually, we use it to extend parts or areas that we need to measure, and it's usually something very stiff, and sometimes it can be machined. A lot of times we use a yardstick or something like that as a straight edge. But if your shop happens to have a straight edge, use it. It's going to help you because it's not going to bow in the center when you try to put it on there. So it's going to be something quite stiff to help you out. And really a straight edge extends the part itself so that you can make an accurate measurement. Does that make sense? Yes? No? No?
Is it like to have both pieces straight? from
Well,
one
okay,
another?
so like if you look at the example that they give here, okay? So it shows right here we have some vertical pieces, right? And they put the straight edge over it.
What's the straight edge? The thing
See that little liney thing right here? See the liney thing? Okay, so they're putting it over it. And we want to make sure, A, that it's straight up and down, right?
Mm-hmm.
But if one is higher than the other, my straight edge is going to lean.
Oh, you know, I was.
So it's going to make sure that it's actually straight and level, and it helps us if I need to measure from here to here, I'm gonna be more accurate in my measurement as well.
Okay.
Does that make better sense?
Yeah, I was looking at the wrong picture.
Oh, that one's the level one. I know that you guys know how to use a level, so we're just kind of skimming over that one. Okay, but the next one, and this really isn't seen a lot unless you've been in construction for a long time. It's called a line level. You guys ever used one or seen one? Really? Okay, so what it is, and I don't think I have one with me, it's a level about this big, and it has two little loop things, and you put it over a piece of string. That allows me to put that string from one side to the other or a very, very long distance and make sure that I'm level across. That's the easiest way to use it. So sometimes you'll see it like when you're gonna throw a chalk line, things like that, because we wanna make sure, hey, we're level, we're on the right area, right? Okay, let's do it, okay? What happens is that if I'm off, what's gonna happen? My level's gonna tell me, hey, ding dong, what are you doing? This isn't where we need to be. Or, oh yeah, that was the angle that we needed, right? So it's gonna tell us exactly, hey, you might be off. Okay, so here's our straight edge. Oh, here it is. So this kind of explains our straight edge. So if you look on page 137, it kind of shows how it extends the distance. This is what I was talking about here. See how it extends it?
Yeah.
That's what I was talking about. So it allows you to extend it so that you're able to read the measurement a little bit easier, okay? Let us go to 139, a plumb bob. Woohoo! Have you seen a plumb bob before, guys? The best way that I can describe it, it looks like a little top. It looks like this, okay? And it's usually brass, and it's heavily weighted, okay? And it's got a point right down on the edge, okay? And they put it on a string, okay? And they want to make sure that everything that's in line with that is in line with it, okay? So that we can say, oh, we're off. If it, hangs one side or the other, oh, we need to make sure that we're using this as our center line. Okay, so that's usually how it's used. And if you notice, in the first drawing, they're actually showing the center line, not only of the pipe, but we're seeing that that plumb bob is with that center line so that we're keeping everything centered. Okay, we're gonna use it in that way. Okay, onwards. A square. You guys familiar with the square? This one? No, a square. Okay, what do we do with the square?
You make sure that the edges is square.
Okay, right? How else would I might use it, or how else may I find out things are square?
What you saying?
Well, not just, what if I don't have that thing?
And to see if two items are straight from one another?
Well, what we can do is, like, maybe I'm doing a frame like this, right? Okay, now if I take the diagonal measurement of this and the diagonal measurement of this, they should be the same. If they're off, we know we're out of square.
So you're gonna use that.
So, but yeah, but sometimes though we don't have, sometimes you don't have the tool. Okay, so sometimes we need to improvise a little, right? What else might I use to make sure things are squared? You guys gonna laugh at me?
You're all gonna laugh at you.
Piece of paper.
Thank you.
A piece of paper.
A piece of paper. Look, tell me what angle this is.
90 degrees?
Right.
90 degrees. Doesn't that look like a square? Okay, this is emergency situation. If I don't have that tool, right, I'm gonna make sure that I'm finding square one way or another.
With a piece of paper.
Okay, so we can do it that way, and I can also show you how to do the angle. The next one is a protractor. Skippy, skippy. A protractor. This finds angles. Now, why is this important in welding? Talk to me. Why is it important in welding?
Well, we're doing angles.
Right.
Well,
Be
we're,
more explicit.
groove joints, you have to do a lot of,
Good.
angles.
So, if I have a bevel, It's an angled plate, correct? I need to know what angle it is, right? I need to make sure that if I have to grind that plate, that pipe, whatever it is, I know what angle to make it. Now, if I make my angle really, really tight, what's going to happen? Think about this. Think about this as two plates. Now, if I make my angle really, really tight like this, what's going to happen?
It ain't gonna go all the way down.
Good, right? You might not be able to access it. Okay, now, what if I make my angle like this?
It's gonna go straight through, right?
Well, it's going to take me 1,000,000 years to fill it up, right? So, usually, included angle is normally between 45 and 60 degrees, which means what degree or what angle must I cut my plate at or grind my plate at?
Half of whatever degree you're choosing, you have to do half on each side, so you divide it in half.
Good. So my most common is a 45, which is 22.5 degree bevel. Okay. The other one is a 60 degree, and that's usually 30 degree bevel. Make sense, guys? Kind of. If not, talk to me. Okay. This is why a protractor becomes important.
So on that protractor, you can find exactly 22.5 then.
Correct.
Can
And
you
then
use
you-
like a little curvy ruler with little lines in it?
If you have one, yeah. Okay. The other one is, and I'm going to have to pull out my magic piece of paper. So there's times when you're in the field and, hey, I don't carry a protractor with me. In fact, I gotta lie, I do. But, okay, so we know that this edge is 90 degrees, right? And you all think I'm a little goofy, I know. Half of 90 is what? Here's your 45.
But sometimes when you fold the paper, you can't really get it corner to corner.
Yeah, but you're gonna get pretty close, right? Instead of not knowing your angle, right? Now, half of 45 is what? 22.5. So now, here's where I marked my plate at. So now I know where to angle and cut my plate with my grinder. I'm gonna measure it, cut it. I have it. Here it is.
Do you remember what kind of angle it is?
Well, now you're getting technical. I think it's an acute angle.
Yeah.
Okay, so, but we need to think about things like that. If you don't have a tool, there's other things that you can use as a tool that we know are square, that we know that can help us, okay?
So with that, you could find out the angle for the bevel?
Yep, you
So-
just saw it right there.
So if the plate is like that,
Mhm.
you wanna make a bevel, 25-degree angle?
Right,
just
so you're
put it
gonna-
against it,
Yep, put it against it, then you'll draw it against it, and you'll know that
and then
that's
you just
bevel.
grind it off until you make that bevel?
Yep, just like that. I mean, it makes it really simple. You know, I carry, I have what is called a magnetic protractor, so I can slap it on whatever, look at my angle, and then cut it that way.
Oh.
You know, those are helpful, okay? But if you're not cutting bevels all the time, it's kind of useless, okay? All right, so it's important for you guys to understand how to use things outside the box. Okie dokie, here we go. Come on, paper. A ruler. Do I need to go over the ruler marks with y'all? Everybody good? Understand measurement? Awesome. All right, we're gonna go on to dividers. Okay, guys, what is a divider?
Devise things.
No, that's a divisor, not a divider. What's a divider?
Use to mark off equal spaces.
Good. Okay, so we can do, so
It describes, it's the pointy thing that you make it go in a circle.
it could, it's almost like a compass. We can use it in that way, okay? But what happens is, okay, so now, so I'm gonna show you here like this. So here's my divider, okay? And say I want to make sure that I have 4 of these, right? So I'm gonna measure it from here, and then I can go like this, and like this, and like this. And now I have 4 of them.
You know,
Pretty cool, right?
These tools we used to get them as kids, right? They
Yep.
they used to come in plastic, used for school. Didn't even know what it was for.
Right, and so, and then the other, we can use it as a compass, right? We can use it as a compass to scribe a circle.
Yeah.
We can also use it if we need to, and we can scribe on our material. But in all actuality, I use a piece of tungsten. Tungsten is very hard. If you sharpen it and you line down your metal, it actually makes a scratch into it, and it's a silver scratch that does not go away. So when you cut or when you need to weld, it's accurate. Here's the only caveat to that.
It's heavy.
Nope. If you mess it up, it's scratched into your material. You'll have to grind it off.
Ooh. Are you talking about the tungsten from the TIG machine?
Mhm.
Oh.
Okay, but we're going to use it. We can use the divider in that same way as a scribe.
And you won't scratch it.
Oh no, it'll scratch it.
You don't have to grind it out.
You don't have to grind it if you're accurate. If you scratch the wrong one, that's when we have to go, oh shoot, that wasn't the right one. So sometimes, and you'll get a little, I would get like a little piece of sandpaper and take it off. Okay, so but dividers are really helpful. Okay, and as we can see here on these next couple pages, they're actually using dividers to find the center of a pipe in order to put a piece in there so that they can to machine out the center to make sure that it's correct so that we can measure it. Okay, so we can use it in many different ways. If I need to, and if we look on the next one, if I need to scribe and cut out the pipe, I can scribe it around and make sure, oh look, here it is, I'm marking it here, I'm scribing it, this is where we need to cut to. So it makes it a really good tool to have, and especially if you're doing a lot of layout, it's imperative that you have that. And that way you're accurate in your cuts and when you lay out your material. The other one is called a trammel. I don't know, you guys are kind of a bunch of youngsters, but old school paisas would use it. And the simplest version is a board with a nail in it, 2 nails. Okay, so that's really what it is. It's a piece of material, okay, a long piece of material, and it has 2 pokey ends. Okay, now we can use it kind of in the same way as a divider, but a lot of times they use it to make circles, large circles. Okay, so usually it's a 2x4 with a couple nails in it. Okay, works the same, and one hold down and the other one you, okay, and it works in that same way.
And that's called
It's called a trammel. Okay, so you can see there's 2 little pokey bits, okay, and then you just whip it around, or you can use it for really large measurements. Okay. All right, chalk line. Does anybody know what a chalk line is? What is it?
It's a line with chalk that you pretty much pull and it marks the straight line.
Good. Okay, so what happens is, it looks like a little box like this. Has a little thing. When you pull it out, inside that little box is actually chalk powder. And they use a piece of string in there. The string gets saturated with the chalk. And you pull it out. You know, and usually it takes 2 people to do it, one from one side and one from the other. And we want to go from maybe one side of the room to the next. One person's going to hold it, you hold it tight, and then they go blink, and it hits the floor in a straight line. And then it leaves a mark. Only thing is that sometimes chalk lines can get rubbed off. That's the only problem with sometimes with chalk lines or even soapstone, is that sometimes it can get, you know, rubbed off. But it's the best way to put a long straight line down. So if we're using, you know, if we have a short piece, it's probably not the best thing to do. But if I have a piece the size of this room, I want to use a chalk line.
how would you know it was straight though?
Well, that's when you have to make sure that your measurements are correct. So I know that I'm 2 from this door and 2 from this door, and that's where it needs to be. So that's where I'm gonna throw my chalk line. So one person stands there, one person stands there, make sure it's accurate, and then somebody else plinks the chalk line. Okay? Yeah. We can be off. We just have to make sure that we're not. Okay. Oh, this is kind of fun. I don't know that you guys are gonna use it. A transit. Now, this is an old school kind of transit. The newer transits actually are all digital and all super fucking cool. Okay, but what this is they usually use it for surveying, and we want to see an angle. How far of a grade is this? Okay, and you'll see sometimes guys in the middle of the road, and you're like, what the hell is that guy doing in the middle of the fucking road? He's gonna get hit, right? And he's got this little box on a tripod. Okay, that's a survey guy. So he's looking at the slope. Okay, he's trying to see if the things that he's looking at are higher or lower than they need to be. Perfect example would be trying to find something in a straight line. So if I have to build columns, I want to make sure that they're all within that line, right? Because what happens if my column's off? Yeah, my building might be a little crooked, right? Okay, or we need to make a slope that comes up this as the base of a building. So that the slope has to be, we have to understand what the grade of the slope is. So it comes with some mathematical computation. So if we look on this other side, it shows, oh look, so if we're looking at this, if I put it so high, I have to start to do some computation to what I'm looking at. That's really what it is. You're probably not going to use it very often, but it's good to understand what it is. Okay? Okie dokie.
Slope for the slopes.
Huh?
Slope for the slopes.
Go, go, go. All right, a height gauge. These can be used when we're doing layout or setup. So if I need to find the center of something, I need to make sure things are on or off or wobbled or anything, I can see how tall they are without having to put a measuring tape, because I might need to make sure that everything is within this height. Okay. All right, the other one is calipers. And usually they have a dual caliper, and it will find an outside or an inside dimension. Okay? So the outside kind of goes to the outside, the inside goes to the inside. Pretty simple, right? But they're very useful tools. They're usually quite flat. And we're most often going to use them probably finding the inside dimension of a pipe. Okay? All right, I got one, I think that's it. Huh? Oh, one more. The combo square. The combo square is a combo square. This does about 10 different things. This is one of the tools that I suggest you put in your toolbox no matter what the fuck you do. Okay? A combo square has a lot of things that you can do with it. Okay, so we can see one piece allows us to determine angles. So we just went over protractor, right? So it helps me with the protractor. It has a protractor on it. Pretty cool, right? And it has a little thing that I can extend so that I can mark my line. Pretty cool, right? Okay, I can also find the right angle or the 45-degree relationships. I need to make sure something's square. Okay? I can, protractors, I can locate the center of a circular object. See that little thing like that? It slides back and forth and I can find the center of a circle. I can measure the depth of something. This is what I use it for most often. So you see this little square edge right here? You can move it back and forth, and if you loosen it just a little bit, you can make this longer or shorter, and you can actually put it in there like number 6 right here, that little teeny tiny 1, 6. I don't know if you guys can see it right there, number 6. So you can push it down and find how deep something is and make an accurate measurement.
Is this all one piece?
So what there's 3 little pieces that actually slide on this ruler.
Oh, okay.
Okay, and there's usually a level on it. I can find out what's level, what's square, and then also I can scribe off of this. So then I'm using my sharpened tungsten or my scribe or my dividers to help me lay out.
Can this help us with the bevel angle?
Yes. So that middle one right here, see how this little piece extends? So I'm gonna, put in my angle that I need, and then this piece extends so that I can scribe it right onto my material. Okay, this is one of the tools that definitely needs to be gotten.
Do you have one?
I do have one, not here. I have about 20 of them.
I want to like see it.
I'll have to bring one in for you guys, but I mean, it's really, really important tool that I use. I probably use it with that and a level, or excuse me, a square all the time. It's a really important tool, especially if you're doing a lot of layout. Okay, I want to make sure something's accurate. This helps me doing it. If I don't have some of those things that, the tools that I needed, this tool kind of covers quite a few. Okay? All right, does anybody have any questions for the material today, yesterday, the other day of the week? I screwed up my weld, what do I do? No? Y'all are too quiet. Okay, guys, please, remember, we need to make this live. So, please like us, please subscribe us, please share us, okay? We're adding Cash App to our stuff so that you guys, if we have a little donation money, we can get better cameras, we can get better things, and I'm also working on getting us some merchandise so that we can actually make this fucking cool, okay? All right, guys, as always, weld the world.
Please like and subscribe.
Weld the world.